diagram you can see here. Horizontal means it is pipelining. Vertical means it is parallel processing. Both are 3 levels. Okay, M value 3 and L value also 3. Okay. So parallel processing means these are the stages. L value 3. Parallel system, L value 3. And horizontally you are cutting into 2 subdivisions. Okay. Here M value equal to 3. And this is pipeline. So when we go with the propagation delay, okay, so it becomes C will be C by M, okay, beta V naught divided by K into beta V naught minus Vt whole square, okay, and L times C V naught divided by K into V naught minus Vt whole square. So all these things are there. And what we have done here, this is for this portion, it is for pipelining. This portion, it is for pipelining. So C will become C by M. Okay. V naught will become beta V naught. These two things are introduced in pipelining. And here this is for parallel processing. This is for parallel processing. And in parallel processing, what is the thing? In parallel processing, what will happen? This T sequence is changing to, okay, L into T sequence. T sequence is changing to L into T sequence, that is there. And if you equate, okay, if you equate, what is happening? If you equate with and without, okay. So without pipelining and parallel processing, the propagation delay is C into V naught divided by K into V naught minus Vt whole square. Okay. You equate the RHS. And here when you cross multiply, M and L will go together. Okay. And then left side it is, when M and L will be transferred together, it is beta V naught minus Vt whole square will come on one side. Okay. Then this denominator, RHS denominator, when it goes to the left side, only beta will be there. And this V naught minus Vt whole square will come on the other side. So now, in this equation, we have supply voltage 5 volts. And threshold voltage 0.6, supply voltage 5 and threshold voltage 0.6. Okay. And M value 2, because we are dividing the horizontal into 2 halves. Okay. So M value 2, sorry. Here you can see division, 2 divisions only. Okay. So this is first division. This is second division. This is first division. This is second division. So pipelining M value equal to 2. Okay. And M value, this is pipelining M value 2, but L value equal to 3. Okay. Here screen on my laptop, I have installed a software. That's where this is coming. L value 3. You can see it in the PPT later. Okay. So when you substitute M value 2, L value 3, supply voltage 5 volts, threshold voltage 0.6, all this in the equation 3.43, and simplify, beta value will come as 0.16. Okay. No, power consumption is reduced. Beta value is coming at 0.4. Okay. 0.4. Left side, I have written equation for without pipelining and parallel processing. Right side, I have equation for pipelining and parallel processing. 3.43 is the final equation. Okay. After equating the RHS, when you put all the values, when you substitute all the values, the beta is coming out as 0.4. Beta value 0.4. So next, when you go with the ratio, power consumption, okay, with the pipelining parallel processing, power consumption, without pipelining parallel processing. In previous problems, we came to See, it is beta square is the formula. So 0.4 whole square, which is 0.16. In percentage, it becomes 16%. Okay. In percentage, it becomes only 16% power is required comparative to 100% when the case is without pipelining and parallel processing. Okay. So only pipelining introduced, it comes at 36%. Only parallel processing introduced, it comes as 43%. When both are introduced, it is coming as only 16% power consumption is taken when both parallel processing and pipelining are introduced in the FIR digital